Another way they often use quadratics is when you're maximizing profits and revenue. So this entire chapter has been about quadratics, and this is just another type of word problem you might see. Profits and revenues. Today we're talking about money. The apartment rental company. They have 1,600 units available. That's a lot of apartments, but only 800 of them are currently being rented. At $300, where's that? That's not anywhere around here. Per month. A market survey indicates, okay, so this is where I get out the red pen, that for each $5 decrease, if I make it a little bit cheaper, then 20 new leases will be signed, 20 new apartments will be filled in. So you want to try to figure out how cheap should I make it so I get more money, but not so cheap that I'm not making any money. Okay? So this is how R of X is going to work. R of X. Okay, R of X is the total rental income realized. So how do you make money? Well, you have so much, you charge so much for rent, money's coming in, and then you have times by so many units. So however much you charge times that many people that are living there. Okay. Determine a function that models the total rental income realized. Okay, so I'm going to make an R of X equation where X is the number of $5 decreases. See how it says for each $5 decrease? So that is going to be your X. So how much money do they currently charge for rent? $300. They currently charge $300. And is the amount of money going up or down? It's going to be going down. So they're going to decrease the price. Are they just going to decrease it $5? No. They're going to decrease it once, say $5. Decrease it again, say $5 more. So that means they're going to decrease it $5 for every X. If they decrease once, minus 5. If they decide 2 decreases is going to take care of the job, then that will be 2 decreases minus $10. Okay, how many units do they currently have rented? 800 units. There's 800 units being rented, but that number is going to be going up. How many more apartments are going to be rented? Well, it says every time you decrease, 20 new leases. So 20 more people? Well, not necessarily. If I decrease it twice, then 20 and 20, then 40. So it's 20 leases for every X. Okay? So the moral of the story, you put the initial number, and then this is going down as this is going up. So you decrease it, I don't know, however many times X times the amount, and then plus X, however many decreases, you get that many more. Now we are going to have to multiply this out. Before I do that, though, I'm going to write here that X is the number of decreases. And you have to kind of look for that in the problem somewhere. But it's either decreases or increases. Okay, here comes the fun part. When I multiply firsts, what's 3 times 8? 24 with 4 more zeros. 24. 1, 2, 3, 4 more zeros. When I do outers, that's going to be plus 6 with 3 more zeros. That's 6,000x. Inners is going to be negative 40 with 2 more zeros x. And the last is negative 5 times 2, 10 with another 0. That's 100x squared. So if I write this in descending order, negative 100x squared plus 2,000x plus $240,000. Okay, let's go ahead and draw our graph, R of X. R of X. So the axes, look at your equation here. The variables are X and R of X. What does X stand for? You should have realized what X stood for way in the beginning when you started making your equation. And so that's the number of decreases. How about R of X? That usually is in the first question. It said make an equation that models total rental income. Then that's what I'll call it. Total rental income. Okay. How about a y-intercept? Where does this graph touch the y-axis? The y-intercept right there. Holy cow, $240,000. And it's a parabola opening down. So if I decrease the rent, I make it go down, I'll get more people, more money, more money, more money. But then I start making it so cheap that I actually lose money. What rent will yield the apartment company the maximum monthly income? So if I take a look up here at H, K, I really want to know what rent. So let's come up here. Rent is right here. Rent is 300 minus 5x. For me to figure out rent, I would need x. That's the H calculation. Well, what does K tell us then? K is the total rental income that the owners make. That's the total amount of money they make. That's not the rent. So to do this one, I'm going to have to do an H calculation. Negative B is negative 2,000 over 2A, which is negative 100. Negatives cancel, the 2's cancel, and a 0 and a 0 and a 0 and a 0 cancel, so the answer is 10. That's 10 decreases. Okay, now hang on, I haven't answered the question yet. What rent will give them the maximum monthly income? So I know rent was 300. But I have to subtract 5 x's, 5 decreases. 5 times the number of decreases, which is 10. So let's do $300 minus 5 times 10 decreases. So that means that rent is going to be how much money? $250. I probably should have made that number be way higher for rent, more realistic, but then way harder calculation. So not realistic, but at least it was more doable this way, right? So here's the gist of the story when it comes to money. Here's the idea. You have a certain cost, and you have a certain number of items. Okay? And as one goes up, the other goes down. So one of them is going to get a plus, and then one of them is going to get a minus. I make it more money, more money, more money. I lose some people. Or maybe I make the cost go down, 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 and I get more, more, more people. Okay, you multiply R of X out, so we can find H and K. So we can find H and K, use the formulas. Okay, and X is always the number of either increases or decreases, either or. Okay, and so the way this looks is it's going to have a certain starting point. It's going to start here, go up, 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 and then come down, down, down. Okay, that's the gist of it. Let's go look at another one so you get the hang of this money thing. A new cell phone company charges $50 per month for their cell phone packages. That's pretty reasonable. There are currently 1,000 people with this company. Okay? Oh, here comes the clue. A research study has shown, let me get the red pen, that for every $2 per month decrease, I'm going to write down right away, X is going to be the number of decreases. So they're telling us here, every time I make the plan $2 cheaper, 200 more people will join. Of course, I'll switch over if they make it really cheap. Okay, so how is R of X going to work this time? Remember how I said that it's always the cost. Okay, so how much does it cost? Times by the number of people. That's how they make their money. However much they charge times the number of people. Okay, but the study has shown maybe they should make it a little cheaper and get some more people coming with their company. So let's go ahead and write an R of X equation. What's the current cost? $50. Okay, and is that cost going up or down? Well, it says that they're going to decrease. They're going to go down. Are they just going down $2? Maybe not. They're going to go down $2 times every X, however many decreases they decide it's going to be beneficial for them. Actually, we're going to do that for them. The number of people is 1,000. 1,000 people are at that company, but we're going to get more people. So that number is going to go up. Is 200 more people going to join? Well, 200 for every X, every decrease. We do have to multiply this out so we can do our H and K calculations. First is going to be 5 with 1, 2, 3, 4 zeros. Outers, 5 times 2 is 10 with 1, 2, 3 more zeros X. Inners is negative 2 with 3 more zeros X. And last is negative 2 times 2 is 4. 2 more zeros X squared. So here's the R of X equation. Negative 400X squared plus 8,000X plus 50,000. Okay, let's go ahead and make our graph. I'm getting the hang of these graphs. Quadrant 1, x-axis. This is R of x-axis. Let's see, R of x, they told me right here, models the total profit realized. Okay, so this is total profit. Total profit. And X, I wrote that down right away when I realized X was going to be number of decreases. Okay, how about a y-intercept? Where does this graph start? It starts at 50,000. So that company is currently making 50,000. But if they keep decreasing their price, they'll make more. But then they start making it so cheap that they actually don't make enough money. How many decreases should the company make? So if you look at your H and your K, decreases clearly goes with H. H equals negative B, negative 8,000 over 2A. I'll cancel negatives. Let's see. I'll cancel a 0, a 0, a 0, a 0. So now I'm down to 80 divided by 2 times 4, which is 8. So I'm getting 10. 10 decreases. No, the answer isn't always 10. It just happened to be that for these two problems. So what monthly charge will result in the biggest profit for the company? Okay, so it's not asking for biggest profit. It says what monthly charge will get them the most money. What monthly charge? Let's see, let's go back up here. It's costing people right now $50. Here's the cost. But we have to figure out if I decrease $2, and I do that 10 times, let's bring that down here. $50 minus 2 times 10. So if I decrease by $20, so the answer is $30 per month. If you had the option of going with this company for $30 a month, would you? I know I would. Okay, we got a couple of review problems here just to make sure we're doing everything else in the chapter correct. The Little League baseball team uses a throwing machine to help train 10-year-olds. It throws the baseball straight up from a height of 3.5. Okay, so it's not from the ground. So it's starting right here at 3.5. It's throwing the baseball up. Nice little pop-up. They can catch it. The ball would come back down and hit the earth if it could. Hopefully the little kid there is catching it, though. What should the initial velocity be? Do you guys remember how to do initial velocity? Okay, you have to find the V0. There's a special technique to this. The maximum height is 67.5. So on my graph up here at the maximum height, that's going to be a y value, I want it to reach 67.5. That's the maximum height. I know this is the h of t axis and that the y number is the height, but that's the maximum. That's not just any y. That's the k value. Remember how to do these? You do a K calculation. Okay, so far in my equation, I know it's negative 16t squared. I do not know the v naught t. I know the initial height is 3.5 though. Okay, so I have part of the equation. Our job is to find the v naught, and we'll do a K calculation to figure that out. So K equals C minus B squared over 4A. What's the K? 67.5. And the C is 3.5 minus V naught squared over 4A. So the first thing I'm going to do is subtract 3.5 from both sides. Oh, that's cleaning that up nicely. 64 equals, let's cancel these negatives, V naught squared over 4 times 16. And you could cross multiply or multiply both sides by 4 and 16. But don't actually multiply, just write it all down. Because remember, we're not going to make big numbers, we're going to make small numbers. We're going to square root both sides. And V naught is 8 times 2 times 4. 64, let's put some units here, feet per second. Okay, some review in case you see that problem in your future at all. Alright, we're going to take a look at some diagrams here, and we're going to write the correct area equation for the directions. They want the area to be the total area. I think what I need to do here is maybe label the new width and the new length. So I noticed that here is a 4. It used to be 4, but then it got bigger. That's 4 plus 2x. And this length down here used to be 6, but it got a little bigger, so that's 6 plus 2x. So the a of x equation for this one would be this times this. I need to write this again here. 4 plus 2x times 6 plus 2x, and now I'll have some space to multiply it out. In descending order, 4x squared. Hey people, what do those outers and inners make? Oh, good, 20x, and then the constant is 24. This area is for the total, it's all that area. Oh, but look at this. Question B only wants the area of the border. How do you find a border? You have to cut out this middle piece. We have to take out this. How much area is this center section here? 6 times 4, 24. So let's take our total area. Let's take our total area. We'll take the total area, and then we'll minus off the piece in the middle, and then that would give us the border. So a of x equals that equation minus 24. Okay? If you need me to explain this to you again tomorrow, please ask. Okay, number 2 wants us to look at that diagram and find the total area. Total area. So that means I'm going to have to do the big width times the big length. Alright, it used to be x, but then it got bigger, bigger. X plus 6. Make sure you put parentheses around your quantities for when you're multiplying. The length down here used to be 2x minus 5 plus 4 plus 4. That makes 2x plus 3. All right, let's go ahead and write the total area equation. A of x equals x plus 6 times 2x plus 3. So in descending order, 2x squared. Hey, what's the outers and the inners? Plus 15x plus 18 total area. Okay, number 3. We're just going to set these up. We're not going to do any calculations. Let's just practice reading a problem and making an equation for total revenue. Total revenue equation. The ice cream cones cost $5, and the cafe is selling them for 25 cents per day. They're selling 25 cones per day. The cost is going to decrease by 25 cents. So X is number of decreases. They would sell 10 more. Okay, so I think we have cost, and then we have number of cones. The cost is $5. Is the cost going up or down? The cost is going down, minus how much? 0.25x. Remember how this works? If one of them goes down, one of them has to go up. So this is the cost, and then this is the number. How many are they selling? Oh, they're selling 25 ice cream cones, and that number is going up. They're going to sell 10 more. 10 more for each decrease. So that's going to be plus 10x. Okay, last one. Let's take a look at this and see if we can write an equation. The cost of a concert ticket is currently $25, and they sell 100 tickets. But if they, for every $10 increase, okay, so X is number of increases. Every time they increase it, 5 less people buy a ticket. I'll make more money if I charge more, but then I won't have as many people buying them. What's the cost of a ticket? $25? Is that cost going up or down? The cost is going up, plus $10x, $10 for every increase. I'll increase it again and again and again. How many people buy tickets right now? 100 people? And is that going up or down? 5 less people for every increase, so minus 5x. Of course, we would have to multiply it out and find h and k, but this is just practice setting them up. Okay, I can't wait to do this tomorrow.